Hey everybody. What you're going to see in this is a smaller clip of a bigger video on solving systems by using substitution. What you're going to examine in this one is, I don't know, what I could refer to as some special cases, some things that may pop up that aren't so usual when you solve a linear system. So I hope that this clip helps out. Best of luck. Okay, so you see on the top of the screen, I've kind of called these special cases. I don't know if they're really special cases, but they might be some situations that don't kind of fall into your normal kind of procedure for us to solve a system. That is, some quirky things might pop up. So I'm assuming we are good with solving systems by substitution right now. So as you're coming into these problems, I'm going to make the assumption that the process for us, the algorithm for us to follow, is pretty nailed down. So I'm going to go pretty quickly through some of that. I just want to address what happens when certain things occur and how we can interpret that. So, as I said, I assume we're really good to be able to solve a system. You see we've got equation 1 and equation 2. I'm going to take equation 1 and I'm going to rearrange it because I see I've got a coefficient of 1 on my x. That's going to get me a 4y plus 8. I can now sub equation 1 into equation 2. I can replace my x with what it's equal to. Oops. I now need to subtract my 8y as I'm copying out the rest of equation 2. Now I can go ahead, expand my brackets. And if I put my variables together on one side, I notice I get 0 y's. Put my constants together on the other side, and I get negative 8. And automatically, I think for a lot of us, we're going to go, okay, this feels a little weird. Maybe you can see where it falls into a special case sort of situation. Okay, how do I interpret what I have now? Well, if I take a look at that equation and I try to solve that equation right now, that equation says 0 times some number, I don't know what that is, has to equal negative 8. And I hope that we're good, that there is no number that when I multiply it by 0, it equals negative 8, because 0 times anything is 0. I can't solve that equation. So I'm hoping we get to it by that point. Perhaps we ended up taking that last equation and we wrote 0 equals negative 8. And I hope that we're good that that equation is not possible. 0 never equals negative 8. So I'm actually writing down something that's not true. So there's no solution to that equation. Or maybe we're taking the gold and we really have the blinders on. We're hardly even thinking. We're just going through a process. And we say, okay, to get rid of a times by 0, I'm going to divide by 0. And now we get that that is undefined because you cannot take 8 or negative 8 and divide it by 0. So we can't define that value. It is undefined. And therefore, there's no solution to that. I'm going to get rid of all of those other colors and leave just the gold. But we get to a point where that gold equation actually has no solution. And therefore, for us to solve the system, there is no solution. That means we can't solve the system. Okay, so what does that mean for the overall system? Well, that means that there is no x value and y value that make both equations true. Okay, what do we have in this situation? Well, I'm going to put down a quick sketch. If I was to take equation 1 and get the y all by itself to enable me to sketch, then I'm just going to jot down equation 1 up at the top. Equation 1 would be 4y equals x minus 8, so y equals 1/4 x minus 2. I'm hoping that we're okay, that equation would have a y-intercept of -2 and a slope of 1/4, pretty flat. That would be my equation 1. Well, if I was to do the same thing with equation 2, and now I'm going to take equation 2 and get the y all by itself, then 8y is going to equal 2x minus 8. Y equals 1/4 x minus 1. You might be able to see that those two lines are parallel. And if solving a system means that we're finding the points of intersection, then two parallel lines do not cross. They don't intersect, so there is no point of intersection. That we might be able to see why our system actually has no solution. So I want to get rid of the picture so that we don't get lost in any sort of possibility of, oh, so wait a second, so when I solve my system, I have to sketch or I have to graph. No. But we need to make sure that we are good for what happens if we get a no solution part to solving our system by substitution. If we get to a case where we get no solution on that, we have to make sure that we interpret that really what that means, it never has to be written. You can just write exactly what you see in gold. That there is no point of intersection. Okay? A little bit of a special case. Okay, let's try one last special case. You'll see on the screen the system I gave you in H. And I want to address the exact same thing. We are good with solving a system, but what situations may arise? Well, you take a look at both equations and you're like, ugh, none of them have a coefficient of 1. Well, if I took equation 1, though, and I got the y all by itself, then, well, when I divide out my 2, that doesn't help me. I still have a fraction. But when I divide out a 2, at least there I get a whole number, an integer. So for me then to sub 1 into 2 isn't too bad. So replace my y with what it's equal to in equation 2. I can now expand my brackets. Well, hey, this works out really nice. 6 times 3/2 is 9. So since it's a negative 9. Nice. And now when I go to collect my variables and collect my constants, I get that. 0x equals 0. Okay, so how do I interpret that? Well, what that says is 0 times some number equals 0. And we have to try to figure out what number that is. And I'm hoping that we're good. When we look at that gold or the orange, we go, x could be anything. Because 0 times any number is 0. So there isn't one value that x could be. There's actually infinitely many of them. So what does that mean for a solution for us? Well, it means that there are infinitely many solutions for that equation. So I'm just going to get rid of that orange, and I can now state that there are infinitely many solutions. Last time we saw, hey, there was no solutions. This time, infinitely many. Okay, what does that mean? Well, I'm going to let you play around with that one. And whether you want to do some sketches on your own, whether you want to hop onto Desmos and use some graphing software to graph both of those lines. But I think you're going to come up with something that is going to completely justify or make sense for why we have infinitely many solutions on equation 1 and equation 2. Okay, I'm hoping that you picked up for solving some systems using substitution. Pay attention to what is the algebra within the solution, and then all that blue stuff I was writing down every time. I'm telling you, if you make sure you write down that blue every time, you're going to drill in that process. Okay, your job now, jump in and get some practice and make it automatic. Okay, best of luck.